Hey guys, welcome to Code Decode. Nowadays, there's lots of fuss about the system design and it's being asked not only in the product-based companies but also in the service-based companies, even at a very low-level experience also. So what is all about system design and how difficult is it? Trust me on my words, system design is something you do in your everyday life. It's just that you don't know that is high-level design or low-level design. It's just that you do it, you don't know it. So today in this video, I'll be making you aware of your own things that you do in your day-to-day life and what is it called, a high-level design, low-level design, and how to approach such questions in an interview. Because you do it every day, but in an interview, you just have 30 minutes to do it. So how to cater such problem, how to think in that direction, and how to move ahead with such system design questions. So let's get started. First of all, let's understand what is a system design. So a design of a whole system, like for example, YouTube or a university management system or an e-commerce website or a cart in an e-commerce website. All these are the examples of a system design. In every day-to-day life, you will be working on some systems, right? Either your application will be an e-commerce website or an insurance management system or XYZ management systems. So all these are systems that somebody has architected for you and you are working upon it. So the main backbone of a system design is the architecture, which consists of its structure, behavior and view of a system. Next comes modules and components. I'll give you an example. Suppose we have already seen the Spring Framework things, right? In Spring Framework, this is a data access or integration module. One module consists of multiple components and multiple modules becomes the whole architecture of Spring Framework. So the whole architecture consists of multiple modules and multiple module consists of multiple components. Suppose for example, data integration is a module, ORM, OXM, transactions, these becomes the components who together combinedly makes the module. So module handles one specific task. This module is only for data integration. This module is only for web interactions. So it handles only specific task in a system. It is a combination of modules which makes up the whole system. So whole Spring Framework is made up of multiple modules, as you can see. Then comes components. Components are particular function or group of related functions. Together these components collectively make one module, capable enough to do one single task. Then in your system design also we have multiple classes and interfaces so that we can share and exchange information between them. And the thing that is getting interacted between these interfaces and classes is called data. So this is the management of information and data flow, and that is the important part of the application. Because you can design anything, you can design any kind of architecture, but it should be capable enough to handle tons and tons of data as your system grows. So all these together satisfies to become a proper system design for a particular system. Now that was too much theory. Let's understand in your day-to-day life how you actually work with the system designs. Hey guys, there's a super amazing app called as Next Level, recently launched by Unacademy for you. Next Level is an ultimate platform for you to showcase your expertise and skills and get professional ratings. The better is the professional rating, the better is your job opportunities. Yes, this is the application where you will have job opportunities out there for you, waiting for you. This app is now available on iOS as well. The playing time is also increased from 10 AM to 10 PM when you can play with your opponents. Also, they have amazing prizes. For rank 1, they have MacBook Air, rank 2, they have iPad mini, rank 3 for Kindle white paper, and also top 25 people have the certificate of appreciation. There are many coding competitions on the application. All you need to do is participate in these coding competitions. We are also providing the invite code in the description below. Please use that while signing up for the application. Compete with the people, win the coding rounds. The more you win, the better is your rating. The better is your rating, the more is the job opportunities unlocked for you. Yes, they have multiple partners across the multiple domains, like in IT services like HCL, ECS, Infosys, SAP Labs, in e-learning platform also like Scalar, Simplilearn, in finance department like ICICI, in e-commerce department like Cashify and many more. At Next Level, even the physically disabled candidates can apply for Node.js and Python positions. You can invite your friends and challenge them to coding competitions. The best part is the app is completely free and the link to download the same is given in the description below with the code reference. Right now you will need to join the waitlist. You can start playing on the app as soon as your waitlist is confirmed. So hurry, download the app, join the waitlist to get the early access to the app. Also do not forget to refer to your friends so that you can get ahead in the waitlist. If you are a software engineer and you are in the IT world, then in every day you actually work with system design. We are given a requirement from the client and our task is to implement that. Now, being in an organization, in a team, we have some set of people. You must have some architects. You must have some developers like SD1, SD2, senior developers and many more. Then you must have some database administrators. If budget is there, great. Else even developers have to maintain your databases. Then you will have people for server management if server is your on-premise server, and the cloud managers if things are on cloud for you. Then you have managers to manage all these people and many more. That is a hierarchy of a team in an organization. You might be at this level, this level, this level, but at all levels you will be doing the system design. I'll tell you how. Now on the start of project, we gather all the requirement in SRS, say software requirement specification document. So there is a client. That client asks you to implement some system. They want some solution for a problem. Now that solution can be he wants to have an e-commerce platform, or he wants to have a management system like insurance management system or employee management system, resource management system. Many kinds of problems are there outside. He comes to you with such a requirement in a documented format. Now it is our task and this team's task to implement and at the end give it a workable solution, and that's what we are paid for, right? So our task is to convert this requirement into a working model, and that is called as designing a system, implementing it and delivering it. Now as soon as you have your requirement with you, the next task comes for the architects. The task of architect is to design the overall system, and that is called as high level design. So you might have heard about system design, what the fuzz is, high level design, low level design, machine code, interview rounds, what are all these? So this is nothing but something that you do in your everyday life. High level design is actually done by architects, and the low level design is done by software developers like SD1, SD2, many people you have for development purpose. So what is expected out of architect is to design the system in such a way that it not only caters the requirement but also with the right set of tools and software services out there in the market. So task of architect is to design the overall high level design. Now for example, you need to store user information that is a part of the requirement in the SRS document. Now the task of technical architect becomes to decide which database, be it a relational, NoSQL, graph, which particular database is to be used. That becomes the task of architects. Once you decide all the components, modules, their interactions, how data will flow between them, then comes the task of developers. Now what the developers do? If you follow Agile, now these all components and modules will be divided into sub-problems, individual sub-problems, small components, and each component will be started to get implementing in the low-level design. So that at the end, you cannot just give the design. So here till now you have done all the designing part. Now here comes the development part. So we divide these components and modules into individual sub-problems and start getting into what is called a low-level design and machine coding. Now this is the task of developers. So now is the time to implement your design you have done in HLD by the technical architects to a working model which will be deliverable to the client. So in your IT life, for sure you will be involved in either the low-level design or the high-level design or even both. Many a times I've seen that even developers help the architects to design your system. That's where comes the knowledge of the system design is important. Now it's not just that developers will only develop and just write the code for all the designing that has been done here. Here comes the real essence of development designing. For example, designing the ER diagrams. You develop entities and you develop their relations between those entities. You develop UML diagrams, class diagrams, activity diagrams, and many more such diagrams, so that when the client agrees upon that, yes, he wants a solution where these items interacts with each other in this way, and this is how data is flowed, and this is how your day-to-day life will go on with such system, and your problem is thereby getting solved. When these designs are approved, then comes the real story where you implement such diagrams into your working model, being it in any language, Java, Python, whatever. So system design is not bounded to any language. It is actually bounded to the concept and the understanding of the whole system. How you solve a problem with all the tools and techniques available out there in market. For example, for the database, you have NoSQL database, Cassandra, relational databases, graph databases, multiple databases are out there in market. Now it is your knowledge on each of the databases, their pros, their cons, which will help you decide which is best for your problem as of now. Hence, it's more about the conceptual and knowledge you have for the market and the tools available which you can implement to solve your problem given. So now what we have understood is either at any of the level we might have either done the HLD or LLD or machine coding, anything or even everything. So we understood the technical architects do the HLD. So why are we developers are asked about HLDs in interviews? At even 2 or 3 years of experience, we asked HLD. Why is it actually asked from, it's such a slow experience? Why is it not asked only for technical architects? Yes, HLD is a task of architects, but these are being asked about even at a very low level, because at this point of time in IT, the candidate is at least expected to have basic idea about these terminologies like what is load balancer, what is caching, what is compute power, what is SQL, NoSQL difference, which one do you have chosen and why have you chosen, how did you do the data modeling. All such terms and technologies are being used. Reason being, system design at a very high level occurs once at the start of the project. You decide what all components has to be taken. But in everyday life, there will come some bottlenecks for sure in such design. And then we have to modify the design to incorporate the solution for such problems. And these solutions will actually have to be designed by the developers also. So that is why even the less experienced candidates, even at SD1, SD2, you are expected to know these terminologies, because at the end these are used in your system. These will be used in your project to solve multiple problems. So yes, idea about them is very important, and hence it is asked in HLD. They do not expect you to put all efforts and develop a proper YouTube or proper Twitter in 40 minutes in an interview. No, they actually are asking you about the approach that you are following, your knowledge in the market, your knowledge with the tools and techniques available, how do you cater to the bottlenecks, and many such things are actually being evaluated by the interviewer. Now, given a system design interview question, like for example, design a cart in e-commerce platform, simple as that, or even a design YouTube or Twitter. So system design questions can vary from very simple one, design a simple cart, a Pojo, what all things you will have, how it will interact with other microservices, then to how to design a YouTube or Twitter. So this is the range you can have in the system design questions. How will you understand what will be the first step to kickstart design of such system designs? So the first step you will be taking is to understand and clarify the requirement first. So there will be some requirement that interviewer will have in his mind. Now he or she will want you to jot it down in your system design. So first task of you is to go play with the mind of the interviewer, take out everything what he needs, so that your system design at the end will be capable enough to cater to the requirement that interviewer is expecting you to cater. So the very first step, rather than thinking about any component or high level, or the first thing you need to do is to clarify the requirement and narrow down your goals so that you don't complicate things. Now, if he doesn't want you to design a very complicated system, why to go into that? First, understand what he requires and then start implementation. So the very first part is to distinguish between your requirements. The requirements can be of two types, functional requirements and non-functional requirements. What are functional requirements? Those requirements which are really important for a system to work. For example, as a user, you should be able to create a cart. A very simple business requirement. You have to design a cart and put some business logic. The cart size should not exceed the 10 items. So these are all important things that an interviewer requires to have. So these are functional requirements which are required for your system to function properly. Create a cart, cancel the order, you should have a cancel button. So these business rules are the functional requirements to have your system work properly. The next comes non-functional requirements. So these includes performance, security, reliability, scalability, maintainability, availability, and many such parameters. Now these parameters help you understand and determine if your system is designed properly. So these are the bare minimum requirements and these are the cherry on cakes. Basically, these are those requirements which will help your system to be available, maintainable, scalable, with good performance and security in the real world. Let me give an example. Suppose you should have a cart, that is functional requirement. You should not have a cart size more than 10 items, business requirement. But your cart should load in less than 10 seconds. This is a performance requirement. So first you will create a cart, put all business logic, then you will think about, okay, my cart should take less than 10 minutes to load. So these are the performance or non-functional requirements. To have a database call in less than 10 seconds with thousands of data is difficult task. So here is when you can think about having the cache and have it in such a way that the overall performance of the system is also increased. Now done with the requirement, you know what you need to do. Next step is you need to decide the trade-offs. You need to decide, based on the budget and what you have in your hand, you need to decide in your application to move to cloud or to keep it on premise. Do you have enough storage in your on-premise to store all the data, or you need cloud storage? And how frequently are you accessing the data? If the data is more for archival data, which is not being used a lot, then is it sensible to keep it on-premise and keep your resources busy, or to just dump it in the Azure or AWS storage and forget about it, because anyways, it is very rarely used. So such decisions, these high-level decisions to go to cloud or to keep it on-premise, based on the budget you have, based on the resources you have on-premise, multiple cost analysis, multiple estimations are done in the second step. Now it's the time to jump to the data flows. Here you decide what kind of data you have in the system and how this data actually flows between different components. So here you actually choose the database also. There are multiple databases available out there in market. For example, you have multiple relational databases like MySQL, Oracle. You have multiple NoSQL databases like MongoDB. You have multiple graph databases. Many databases are out there in market. Now you will be asking me, why do I learn about everything? Why can't I just go ahead with the relational databases? There can be a chances that you do not have fixed schema. Then relational databases of no use. Sometimes they will give you 2 or 3 columns. Next time they give you hundreds of columns. How will you manage such data into your relational database, which is having the constant number of columns? You cannot increase columns now and then into your relational databases. There comes the beauty of NoSQL databases, where your data is stored in the document format. So choosing between such databases, you have to have the knowledge about market. You have to have the knowledge about types of databases out there in the market and what are their pros and cons, and which actually fits in your problem here. For example, the non-functional requirement says your database should always be highly available. The user data is very important to this company. Then Cassandra is the better use for NoSQL databases because it says it is highly available. So understanding the pros of Cassandra is highly available is useful for you to implement that in your system. Now you know which database to use. Now it's the time to implement the high level design, that is HLD. Remember, always HLD is first and then comes the low level design, which actually takes input as HLD design only. So first you have to design the HLD, and then using that as an input to LLD, you design your low level designs and machine codes. Now you might have seen on the internet there are multiple solutions to implement YouTube, implement Twitter, implement many things. Even there can be a very high chances in interview they will ask you to design YouTube and Twitter. You know the solution. What you can do is just go ahead and just write everything on the paper that you know about YouTube. But then it will be very clear that you have mugged it up. You have not understood the real essence of the system design. Next time if some design question comes which you have not implemented, for example, out of blue moon came and asked you to design an insurance management system. You won't know the basics, how will you implement it? So it is an iterative approach. Even if you know, I would always suggest start with a very basic one, keeping all the bottlenecks and issues in your system, and then remove them as and when the interviewer will ask you that here you have a bottleneck, how will you solve this? So keep it always an iterative approach. Never go ahead and implement what you know, everything at once, removing all the bottlenecks, some perfect solution. Don't do that. I'll give you one example. In a real world, what you do is you create your queries, implement a whole CRUD, end-to-end functionality is up and running in the production. Now after some time, your client might come and ask you that this is taking a very long time. What the first thing you will try to do is to optimize your queries to databases so that your time to front end reduces a lot. To implement such, what we can do is we can use executor service with async communication. What will it do? Suppose I need to go to the database and fetch users and product simultaneously. They are not dependent upon each other. So why to make it a blocking calls? You can first hit both the queries simultaneously and get the result simultaneously. So when first query is taking 2 seconds, second query is taking 3 seconds, if you do it async, the total time which was 5 seconds is reduced to 3 seconds. This is where you do the performance optimization after your system is actually up and running in production. So that is why I say system design is always iterative approach. You implement some functionality, you see, okay, this is a bottleneck. 5 to 10 seconds is a very big time. The client is getting frustrated, and then you go and optimize it to the proper way. That is iterations. Each iteration you make your system design better, and that is what is expected in your system design interview questions also. Not just go mug it up and just dump it on the paper. Don't do that. It will be very much sure that you have mugged it up. And also remember one more thing, there is no right or wrong way to such questions. You might implement it in some way, other might have some different approach, because in the market there are thousands of tools and technologies available to solve a problem. You might use one set of solutions, the other might use the another set of solutions. Both will be the valid design until and unless all the requirements are getting fulfilled. So high level design, what you do? You choose your top level components. For example, to make my cart, I need a cart pojo. I need the date when that cart is created. I need the items in the cart present. I need also the number of each item in the cart present. So designing such components, then also you need a way to store this cart in your database. So you design a database. Also, I know that I will have multiple requests to create cards, so I need it to be load balanced and created in a multiple instances on the cloud. So this is how you design your very top level components. What all things you need to make a system up and running. So how they interact, how data flows, what data is to be stored, what type of database you will use. That decision will be taken in a high level component design. Now when high level design is done, then comes the low level design. And remember, low level design is just an extension to high level design. You might have told in the high level design that yes, I'm going to use caching, so that my time reduces and my card gets loaded in 10 seconds. They might have said yes in the high level interview. Now in the low level interview, they will dig you up completely, asking why did you use caching, which caching did you use, how will you decide how many elements will be there, what will be your time to live in the cache, what strategy you are using in cache, like it's a least frequently used will be going out of the cache first. All such decisions, they will dig you up in the low level design. So yes, be very, very careful while choosing your components in high level design, because you need to justify that, and which particular small attributes you are using in that particular component has to be also decided in low level design. So in high level design, we had our components ready. Now it is time to deep dive into our decision and see how much feasible it is. So just don't panic. Even if you find that, oh, I have used a NoSQL database, I could have used the graph one also. Then also they will give you a chance to improvise it, remove the bottleneck and provide a solution to it. So this is the iterative approach. You design, but you find that it is not feasible. Then you modify it and go ahead. So this is where you start with each and every component, go to the detailing and see their pros and cons and choose. Okay, I have done wrong, let's correct it up. In the low level design, it's not just the designing, it also might be involved with the machine coding also. Many a times, most of the companies have the low level and machine design together. So there will be multiple diagrams that you have to create, like ER diagram, activity, UML diagrams, class diagrams, many diagrams to justify your design and your data flow between these components. And machine coding round, where you need to write some piece of code in any technology that is being asked to support your designs. Now I've already given you an example of low level design, like in cache you have to tell what is time to live, which strategy you are using in cache. If you have used load balancers, which load balancer you have used. If you use service discovery, which side of service discovery, client side discovery or server side discovery, which one is going to be used and why is it going to be used and why is it helpful, why not the other one. All such questions for sure will be asked in the low level design. And many components will be used, like load balancers, CDN, storage, servers, database, and many more. If you want to know about each and every of those, also if you want to know the low level and high level design of all such scenario questions, like design a YouTube, design a Twitter, then please let me know in the comment section. I'll include those videos in this series also. Thank you. Thank you.